Okay, welcome back, guys. So in today's question, we're gonna solve a follow-up question onto the previous question that we solved in the previous video. I'm gonna put that in the link description. But before we start, make sure to subscribe to this channel and share it with your friends who can find this content useful. And let's jump in. So we have this crane that is attached to a cable, and we know the tension in the cable is 14 kilonewton. And in this question, we need to replace this force that is acting at point A with an equivalent force coupled system at point O, and we know that the point B is at the center of the container top. So at the end, what we need to find in here is a force coupled system, which means we need to have one single force that can represent all the forces in the question. And we previously solved the question and we found the tension in a vector form. And that's the only force that we have in this question, and that would be the force part of our force coupled system. And so we found that this was the tension in the cable, and I'm going to put the link in the description below to see how we got this tension in the cable. So that would be the first part of the force coupled system. So this will be our force. Again, we need to find the sum of all forces that we have in this assembly, and here we only have one single cable tension at point A. And the second part is finding the couple in the force couple system, and for that we need to find the moment about point O, since we need to find the force couple system about O. So we need to find our distance vector. So cross at the end we'll have R cross F for the moment, and in here we have to find our distance vector or position vector R. So the question is, which one is our position vector? Is it the vector that connects O to A, which we call it our OA, or the unit vector that connects our point O to B, or it's something in between? Let's call this point C. And the answer is that the position vector is any vector that connects the point that we are finding the moment about, which in this case is point O, to the line of action of the force. So any single point in the line of action of the force, which is the tension in the cable, can be our position vector. But the easiest one is going with A or B. Let's go with A. And then in that case, we need to find the coordinates of point A, and the rest is simple enough. And we will have our OA cross F, which will be the T that we have in here. And for this, we need to find this determinant that we have I, J, K. The second row is always the position vector, and that would be the coordinates of point A, which we covered in the previous question. So I'm going to go over it very quickly. If you look at the X, we'll have 5 for X. For Y, we'll have 12. And what we have for K will be 20. So will be our T, which we know in the previous point, X component is 6.83. We have 5.20 for Y component, and minus 11.06 would be our. So the rest of this is solving this determinant, and for that we have, for the I component, we have 12 times minus 11.06 minus 20 times 520. This would be our I. we'll have a negative sign for J, and we'll have 5 times minus 11.06 minus 20 times 6.83. That would be our J component. Again, don't forget this negative sign in here. And for K, we have 5 times 520 minus 12 times 6.83. And if I want to go over the determinant, what we do is simply, if you want to find the I component, we just don't look at this part, and we have this times this minus this times this. So for I component, we have 12 times minus 11.06 minus 20 times 5.20. That would be for I component. If you want to find J component, again, we cover J. We have 5 times minus 11.06 minus 20 times 16.83. That would be our J. And lastly, for the K, we're going to cover K. And we have 5 times 5.20 minus 12 times 6.83. And that's how we can find the determinant. And if we do that, for the first part, we have minus 237. That would be our I. For the second one, for the Y part, we get 191.9. That would be our J. And the last one is the K, which we get negative 55.9 K. And the unit for this will be kilonewton meter. And that would be the couple part of the force couple system. And the final answer for this question is, make sure to subscribe to this channel and share this content with friends who might find this useful and it can help them in their studies. And that would be pretty much everything. I'll see you guys next time.